So these last few chapters of the textbook, we learned that there are four fundamental forces in the universe: the nuclear strong force, the nuclear weak force, the electromagnetic force, and gravity. Now, physicists think that these four fundamental forces are actually manifestations of a single underlying force, different ways of interacting with matter. And as the universe aged after the Big Bang, these four forces broke apart from one another, leading to the forces we see today in the universe. So the early universe, immediately after the Big Bang, these four fundamental forces acted as one. Now, physicists are trying to combine these forces into more complex theories, trying to understand what this underlying force would look like. And they've succeeded in some respects. For example, the electromagnetic force and the nuclear weak force have been combined into what's called the electroweak force. And that is a theory currently doing quite well, having combined those two, what were thought originally to be separate forces. Now, physicists are trying to bring in the nuclear strong force into that relationship to create what's called the grand unified theory. A grand unified theory combines the strong, weak, and electromagnetic forces into a single underlying force. Unfortunately, this work is still being done. No huge breakthroughs have come through. This is not yet a complete theory. Many particle physicists and theoretical physicists are working on this grand unified theory. Note that gravity is not included in grand unified theories because gravity, if you remember, is 10 to the 38 orders of magnitude weaker than the nuclear strong force. It's ridiculously, absurdly weak compared to the other three forces in the universe. If you want to combine gravity and talk about an underlying force for all four fundamental forces of the universe, that's called the theory of everything. So the theory of everything is trying to create a single overarching theory that explains where the strong force comes from, where the nuclear weak force comes from, where gravity comes from, where the electromagnetic forces come from. Superstring theory is one such theory of everything. But again, we haven't even gotten to a grand unified theory, so adding gravity to the mix is highly difficult and may not pay out dividends for decades. Maybe nothing will come of this, maybe some other type of theory will come about, but this is the current trend for physics, theoretical physics, going forward. Now, some theory of everythings make predictions. Remember, it's not science unless it makes testable predictions. And some of the theory of everything models predict that the proton, right, the building block of atoms that we know of, has a half-life of about 10 to the 32 years. So you're talking 100,000 billion years for the half-life of a proton. To give you a sense of scale, the universe itself is only about 10 to the 10 years old. So the half-life of a proton is ridiculously large, but we also have a ridiculously large number of protons in the universe. So during the course of the universe, even though one half-life has not yet passed, protons should have decayed in the 10 or 14 or so billion years the universe has been around. Sadly, we have not yet observed this decay in nature. If we do, that adds a wonderful amount of supporting evidence to these theories of everything. If we can put limits on proton decay and say, no, protons can't decay, we tested up to 10 to the 50 years. We haven't seen any decay. Not that the experiment lasted that long, it's just that you had that many protons you were studying, so you expect a few to decay in the first early years or decades of an experiment. You can say, nope, this model, this prediction is wrong, it does not support it by the evidence, then you go back to the drawing board and come up with something else. Note that this simple reaction obeys our conservation laws, which we talked about in previous videos. Conservation of charge, and so on. The difficulty involved in this reaction, again, is just, it's not seen. But what this is saying, if the universe continues to go on forever, which is what astronomers currently believe, that there is no end to the universe, and the universe will continue to expand and accelerate until forever, eventually all protons in the universe will decay away and become electron-positron pairs.